All right, data types. Data types is how we declare a variable. What kind of data types can you think of?
Int,
Int x equals 5. Char y equals single quote g, whatever. Y is equal to g. That's ironic. What was the other one you were thinking? Boolean. Z equals true. And what was the last one? A double. And what's the difference between an int and a double? Decimals. So double. So double, float, and there's a couple, and that's worth Googling at some point. And there's also variations like int array of xxg, and that's now we can put in a bunch of numbers. And that technically is a different data type. It's an array of ints. So that's 5. So that's 6 actually. So that's wait, no. All right, 5 different data types. 1, 2, 3, 4, 5. I can count. That's great. And the other one, we can also do string name equals, George, whatever. Yes. So anything, this right here is declaring the data type. And so that's why I always, whenever I think of declaration, I always try to really do think of like a trumpeter, just like announcing, bah, 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 here's a string called name. So that's, I think, old school in my declaration. Okay, so that's declaring different data types, and Google, so at some point, Java data types. There's some funky ones, like short is like an integer that's even smaller in memory. There's a couple ones, you'll never really need them necessarily, but you'll notice that some are lowercase and some are capital. String is not a primitive. These are primitives, and that's why they have special words for them. Again, we'll get more into that type of terminology as we study the difference between heap and stack memory this week. But let's start a for loop. So a for loop has 3 parts. First is the declaration int I equals 0. That's the start of our counter. And then I will keep looping as long as I is less than 3. So that's the declaration, the increment, and the last one is the declaration, the condition, and the last one is the increment. And so now we have a for loop that will repeat 3 times. And so, but I said that it has to print 3 times, and yet I say as long as it's less than 3. How does that make sense? If I said 3 times, shouldn't it be less than or equal to 3?
Well, since you start at 0, it's...
Bingo. 0 indexing. You just want to get that in early because that trips up students all the time. It tripped up me forever. So I just want to keep on repeating that. So now we just do a simple print line statement and say hello, and that'll give me 3 times hello. Okay.
So is that the same thing as if you just put system out for hello 3 times?
Yeah. And so that's called keeping the code dry. If I were to copy and paste that 3 times, that violates a central principle in computer science, which is don't repeat yourself. Dry. And so if I say, oh, you got to dry up that code some, it just means rethink about how you're writing these commands and doing it in such a way that's more efficient and easier to change. Because if I wanted to change that message, I would have to change it 3 different places rather than just one central place. And so don't repeat yourself. It makes more optimized code. Okay, so a for each loop is slightly different than than this for loop that we have. It's more convenient for looping through and spitting out information. It's not more convenient if you're trying to change the information. Let me show you what I mean. So I have a list up here. I'm going to call it listy. Well, it's not really a list. Let's call it my array. Java lists and arrays are a little bit different, and we'll talk about that. But Right now we have my array, and now I could go through that in a sort of structure similar to this, especially if there was only 3 items. This could go through each time, and I could just say, instead of saying hello, I could print out my array at the position of I. So I will start at 0, and this is the 0 spot. And then I will go up 1, and it'll be 1, and I will go up 2, and it'll be 2. And so each time it'll print out the location at that spot. And I could run this and, oh, you know what? Hold on a second. I have to, and there you go. You get 5, 6, 7. It prints it out. So that's simple enough, but there is an easier way. It's called the for each loop. It starts the same way, but you just say for int I in the collection called my array. And for that, you can just do system.out.println, and then I'll print I. So rather than printing my array at the location I, I'm just printing out the counter. I set up a counter, and it will pretend to be each element in this group. So I'll show you how this works. If I run this 5, 6, 7, it printed, and then up and printed again, all the same way through. So really handy. Now, if I can do it, to give another example, if I call a string array called names, and it's equal to Sophia and Drexel and Pete, if I call this, and then I can do for string name in names, and then I can system.out.print. Oh, name is already being used, so that's not cool. That's why it's yelling at me. I'll just change this to n. So now it's cool. So now if I print that, it will go through each one. So name will iterate through or traverse this list and be each one. So it's just a handy trick called the for each loop to help you go through a list of things. Now, you might be wondering, well, why do I need to learn 2 different loops? Can't I just use this one? I mean, this is already hard enough. Why don't I just stick with that? Why use this for each loop? Well, it's shorter and easier, but there is a drawback, and that is if I tried to say, let's get rid of this to make things simpler. If I said my plus my array, this means add 1. So I'll go 6, 7, 8. Now it's 6, 7, 8. So it added it, and now I printed out a second time. But if I did let's switch these, and just for giggles, I did ++I, and then I would just print this out. If I ran this, you'd see it doesn't stick. It did go up, but then I printed it again using the normal array loop, and we didn't see it go up. And that's because this is just a copy. It'll copy into this spot. You're not editing the original thing. So it didn't make a permanent change like it did the other direction. So a for each loop is great for reading, but not for making changes to your collection. So we're going to go over that again a couple more times. So it's no problem. As long as it sort of makes sense now, practice will really help you sink that in.
Also, when it says like traversing string array, like that's just like making sure, or isn't it just like cleaning it up so there are no like bugs or something that goes traverse?
So I'm going to use the same word, the same concept will be used with 3 different terms: loop through, traversing, and iterating. I mean the same thing for all of that. That's what this is and this is doing. That's what these 2 things are doing. Anytime where you set up a loop that will repeat a set of commands for each item in a collection, that's traversing. And so if I read off the list of all of the students in class to take attendance, I'm traversing the list. of attendees. And so I'm just repeating the same command for however long my list is. And so, are you here? Yes. Are you here? Yes. That's traversing. Iterating and loop through, that's the same thing. So there might be, yeah, at least in this class, that's the same thing. Okay, so the next thing is an infinite loop. This is best used when with a while loop. So while will loop as long as whatever in here equates to true. So if you actually just use the literal Boolean true, then it's just going to keep on looping. So as long as true is true, it'll just keep on looping. So it's infinite. So when you say an infinite loop, you can also describe that as a while true loop. So and it's okay. So now a short circuit conditional. Short circuit conditional with 4 tests. So that's an if statement. That's a conditional. So it'll only run the if statement. It will only run the if statement if the stuff inside the parentheses resolves or boils down to true. So if I say if true and false, this will result in this is not out print line. It's even yelling at me because this is stupid. This will never run because it knows right away that both sides of an AND statement have to be true, and I've already failed that. So it needs to. It says true and false. If I said true or false, this would run, and now it sees that it's no longer a problem. But it's yelling at me right here because it's saying this will short circuit, and so it's saying it's dead code because this will short circuit. As soon as you get an or statement, if true or, it doesn't bother with what else is after that. As soon as it knows that it's just this or the other, and then you get something true, it's not going to ever run this code. So that's a short circuit. So as soon as it hits that, it dumps right into here. So this is only 2 tests, and true or false. I mean, this is, here we go. Here's just a ridiculous bunch of gibberish, but it meets 4 different tests. So there's 4 different evaluations happening here, and none of it matters because it's just going to see this and short circuit right in.
So in order for it to be short circuit, it has to be in or.
No, that's a good point. If it's an AND statement, so if can it be a short circuit with an AND? If false and true would also be a short circuit, because as soon as it sees an and it knows it fails, it'll never go in here. And so now all of this is dead code. This is all a dead end. So it's the same thing. Right. So short circuit is best if the first part fails and it's an and statement, or the first part is true and it's an or statement. So either one of those conditions, that's a short circuit. Cool. And so if that's true, and then I can break. And the way you can get out of a loop is just a simple command called break, and that will jump you out of a loop. Okay. So loop through each character in a string. Let me save this and I'll start a new video here.